let's talk about 4.6. So suppose that $3,000 is placed in a savings account at an annual rate of 8.6%. Compounded semi-annually. So this is important. Assume no withdrawals are made. How long will it take for the account to grow to 4,767? Okay. So first thing you need to know is when they mention compounding, you got to use this formula here. And if they're asking for how long, they want you to solve for time. So here's the formula that you're supposed to use. They're not going to tell you which one, but I'm writing it down now. So you need this guy here, and this is what each part means. A is the future amount in the account, future value, future amount. P is the principal that you start with. N is important. That's the number of times you compound every year. So if I compound semi-annually, it's going to be 2. Rate is 8.6, but you got to put it as a decimal. Time will always be in years, no matter what. So if they give you months, you have to convert it into a fraction of a year. Okay, so A is the amount it's going to become. P is principal we started with. N is 2. Semi means 2, twice a year. Rate is 8.6. You have to change it to this. Time is, T is time in years. So we don't know what that is. So we're solving for this guy. So basically we need to solve for T that's up here. So you got to use logs to bring it down. So what I want to do is solve for this in general. That way we can actually create a formula. So solve for T. Introduce, I'm going to use ln. You can use any log. So remember, you can separate products inside. So that's going to be ln(p) plus ln 1 plus r over n to the nt. Ln a is still here. I'm going to move this over, so this will be ln a minus ln p. So I subtracted ln p over. Okay. So now we got this guy over here. So bring down the nt. Divide by n and divide by this. This is a t bar, no plus. Put a little curve in. And then we'll have t. So t is equal to this side divided by n and ln on 1 plus r over n. So okay, so if you use this formula, you can always find time, technically. You can also just plug it in, all numbers in here, and then solve for time, but since I've solved in general, then this is technically a formula. Divided that there, yeah, everything's good. So plug in A, so that'll be ln of 4,767 minus ln of 3,000 over 2 times ln of 1 plus 0.086 over 10. There we go. So punch that into your calculator and you'll be done. No. Let's see what they get. So this is roughly, once you punch it all in, 5.5 years. That'll take 5.5 years to get to make 3,000 grow into 4,767, depending on, or given this compounding and rate. So if you don't want to solve the log, you can use this formula here and just plug in the numbers if it's a compounding problem. Or you can plug it in all at once and just try to solve for t real quick. All right. So if they say compounding semi-annually, use this guy. If they say continuous, you got to use the E type. Let's move on to the next one. Okay, let's go to problem 2 in the homework. So the study is done on the number of bacteria cells in a petri dish. Suppose that the population size P of t after t hours is given by this function, or exponential function. Let's see. Part A, I gave you a bunch of information, so I'm going to talk about the info first. So here's the model they gave us. A right here is the initial amount. This B determines if it's growing or decaying. So A is initial amount. So if it's growing or decaying, if B is less than 1, the B is the number inside, then we have decay. If B is greater than 1, then we have growth. Okay. So part A, what is the initial amount? Well, that's going to be the 2,800, right? The number in front, the A. Part B, do we have decay or growth? Oops. Since B is 0.85 less than 1, we have decay. Okay. Or T, excuse me, by what percent does the population size change each hour? All right, so part C, let me see, formula defining the rate. To find the rate is what you do. You take, I use this formula B equal to 1 minus R, solve for the R. So that's 0.85 equal to 1 minus R. Subtract that gives you negative 0.15. Divided by negative, that's R is equal to 0.15, which is 15%. So that's what you use for part C. But that's it. That's how they solve ABC. Just remember this information with this kind of model. All right, so problem 4. Leila wants to buy a bond that will mature to 5,500 in 8 years. How much should she pay for the bond right now if it earns an interest at a rate of 2.5% per year, compounded continuously? So this is a keyword right here. This is what tells you to use this formula. Also, I solved for P, so that would be this one if you need P. Since they're saying they're giving you the future amount, so they want to know, okay, well, if in 8 years I'm going to get this, how much do I have to start at? How much money do I need to put in at this rate? In other words, what is P? Okay, so just use this formula. So we know that 8A is 5,500. P is what we're looking for. Rate is 2.5, which is 0. Oops. Time is 8 years. So just use this equation, this formula, you'll be good. So they want principal, so P is equal to A times E to the negative RT, which is going to be 5,500 times E to the negative 0.025 times 8. Punch this into your calculator and you'll get the 5 right there. You will get 4,503.02. Yeah, so if they want the amount right now, that means principal. Compounded continuously means use the continuous interest formula. Anyway, that's the main ideas. Let's pause. Let's go to the next one. Okay, so homework problem 5. Rutherfordium 265 is a radioactive substance that decays according to the following function. This models the decay of this element. Y naught is the initial amount present, and Y is the amount present at time t. So t is in hours. Find the half-life. So basically, they want to know, like, when will this element lose half of its amount, probably mass or whatever, right? So if this is the initial amount present of this element, solve for t once you set it equal to half this amount. So set this equal to half the initial amount, whatever that is, and then solve for t, time. You can already tell that y naughts are going to cancel. Now we have this. Remember to cancel e or bring down the t, you need to introduce ln on both sides. Now divide both sides by this coefficient, and we'll have time. So t is equal to whatever this is. And that will be under calculator about 13.1 hours. So in 13.1 hours, you lose half of the amount you started with. But yeah, the trick was setting it equal to half of your starting amount, and y sub 0, we set in the problem, is initial amount. Okay, let's go another one. Okay, so number 6 is pretty similar to the last one we just did, except instead of solving for time, we're solving for r. The this r. So this is the general model. Why not times e to the rt? We're given the initial amount. It says at the start of the experiment we have 897.9 grams, so that's going to go right there, right? So why not? And then it says has a half-life of 8 hours. So that'll be T. Plug in your T, plug in your why not, set that equal to zero point 0.5 that amount because that's the half-life. How long it takes for the half-life? So if you plug that in, if you plug in 8 for time, that corresponds to the half-life. Therefore, you need to put the zero point 0.5 times the initial amount. Kind of like we did before. Once you have that set up, just solve for R. But just like we did in the last problem, ln both sides, e's cancel, divide by 8, and you're good. So we won't work this one out, but that's pretty much what you do. Once you have R, then you do the exact same thing we did in the last question and solve for T. Okay. All right, we'll stop here for this section. So basically, use your um, formulas, either the exponential for compounding or the compounding interest, exponential, continuous interest, uh, and etc. And then solve for the appropriate parts.